This video illustrates two testbeds of our paper addressing the teaching of CPPS remotely at graduate level through digital twins and simulation. Testbed A serves to support theoretical classes by allowing students to clearly visualize the link between the physical and the cyber elements, as well as how changes to one can be reflected in the other. By interacting with the digital twin, different configurations and scenarios can be experimented with to test the ability of the multi-agent-based CPPS to self-organize and adapt in the face of unforeseen disturbances. Testbed B consists of a flexible job shop simulation in competences, used as the basis for the practical assignments of a smart manufacturing course. Here we show an example of the final assignment implemented by the students, in which a multi-agent-based CPPS was developed from scratch to control the execution of the system, in this case mimicking the application of an industrial adhesive to an automotive part. The multi-agent system was then integrated with a deep learning model through a service-oriented approach to automate the visual quality inspection of the product. For this scenario, the students were tasked with developing the CPPS in a way that was capable of collaboratively coordinating the simultaneous execution of multiple products along with varied product variants, with each element of the system being abstracted by an intelligent agent. The adhesive application stations were designed in a way that made them occasionally generate defects in the product at random locations, resulting in varied gaps in the adhesive path. The last part of the assignment entailed training a convolutional neural network to perform the quality inspection, which in this case was framed as a binary classification problem using images captured at the quality stations as the input. This model was then deployed in a server and integrated with the CPPS via web services, concluding the end-to-end solution. Using this simulation as the basis, which is provided as open source with the paper, several variations of this project are possible for similar courses. This can include exploring the data acquisition and machine learning aspect by adding sensors to the robots to enable predictive maintenance approaches, or putting additional emphasis on the robotics side by integrating with, for instance, ROS, which is supported by competences. This approach allowed us to remotely deliver the course on smart manufacturing to electrical engineering graduate students at the School of Science and Technology of NOVA University of Lisbon in Portugal. While the overall level of satisfaction reported by the students was quite high, we also verified that the average attendance rates throughout the semester improved when compared with previous years, along with an improvement of retention in the lab component, with a relatively higher portion of the students submitting their final assignments successfully. We consider that this approach can be used as a reference for other similar courses, effectively contributing to breaking down geographical barriers to higher education regarding CPPS, whilst also assisting in reducing the costs and complex management of scarce resources often associated with such solutions, thus contributing to the improvement of their accessibility.